Thanks for joining me today to learn what's new with hybrid tables. I'll get right to the punchline. Hybrid tables are now officially generally available in AWS. But there's a lot more exciting news to cover. Let's jump in. I'm Philip Coletti, product manager here at Snowflake. I've been working on hybrid tables for a couple of years now, and I'm really excited to tell you about all the cool things that our team has been working on for you to take advantage of. We'll start a little bit by talking about why we're building hybrid tables and the problems that we're trying to solve for our users. We'll spend a bunch of time looking more closely at the feature itself, understanding what it is and how it works. And then we'll bring this into the real world and we'll look at some of the use cases that our customers have plugged hybrid tables into today. Lastly, I'll make sure to leave you with some resources so that you can get hands-on with hybrid tables yourself. Since its founding, Snowflake has been on a mission to break down data silos. We started in the world of analytical data, eliminating silos between different analytical database systems, allowing organizations to leverage the full capabilities of their data and collaborate on data like never before. But there were still persistent silos between different transactional systems and between your transactional systems and your analytical data platform. And those silos introduced delays because you need to move data. They increase the complexity of your data architecture, and they make it difficult to maintain unified and consistent data governance and security. Unistore is Snowflake's approach to simplifying your development and data architecture by uniting transactional and analytical data together in a single, unified, consistent database. Snowflake has long been used as a highly scalable cloud-native analytical database, so it's really the transactional half of this picture that's new to Snowflake. And that's where hybrid tables come in. Hybrid tables are the flagship feature powering Unistore workloads on Snowflake by enabling high concurrency, double-digit millisecond latency point operations natively inside Snowflake, all alongside the petabyte scale analytics that you already run on other analytical table types inside Snowflake. Hybrid tables add support for features that are critical for your transactional workloads, like primary keys, foreign key referential integrity constraints, unique constraints, and additional synchronously maintained secondary indexes for snappy response times on common access paths for your applications. They integrate seamlessly with other Snowflake tables and features. So you can join a hybrid table and an iceberg table, and that join will execute efficiently and natively within Snowflake's one query engine. No federating out to other database systems. You can run an atomic transaction across a hybrid table and a standard table so that all of your data inside Snowflake is always consistent. And in keeping with Snowflake's core product principles, hybrid tables just work. It's like working with any other table type inside Snowflake, but you add the hybrid keyword at the beginning of the table definition, as shown in the snippet on the right. And hybrid tables also require a primary key. But you'll never need to deal with provisioning storage volumes or scheduling downtime for software upgrade windows. All of those types of things are managed underneath the hood so that you don't have to deal with them. I think the most important update for hybrid tables here, as I mentioned at the beginning of this presentation, is that they are now officially generally available in commercial AWS regions for Snowflake. They're not yet available in Azure or GCP or Gov deployments. We'll be working on expanding to those additional cloud service providers and regions in the coming quarters. So that's what hybrid tables are. Let's talk a little bit about how they work. This is the classic Snowflake three-layer cake architecture diagram, and you'll see hybrid tables in that orange box on the bottom right corner of the screen. They are powered by a brand new storage engine specifically an operational row store. That's what allows for high concurrency point operations. But they look and feel like just another table inside Snowflake DB because they are just another table type within one consistent database. That's why it's so important that we reuse the same cloud services layer and the same virtual warehouse query processing layer so that you can access and use hybrid tables alongside everything else inside Snowflake. However, in order to allow you to run low latency queries against hybrid tables, we've also deeply optimized these top two layers of the architecture so that you can efficiently get down to that new storage engine for executing your workloads. Now we're going to double click into that orange box and look at hybrid table storage architecture a bit more closely. So when you work with hybrid tables, they look like one logical table. However, under the hood, we're actually abstracting away a dual storage architecture. The primary storage engine is this new operational row store, and that's what allows you to execute high concurrency point DMLs. All of your writes go directly into that row store. Additionally, we asynchronously copy data over from the row store into object storage. Then when you read from a hybrid table, our query optimizer decides where to read data from. Dramatically oversimplifying this, a high-level rule of thumb is that highly selective point reads that can leverage indexes will go to the row store. Large scans will go to the object store. However, regardless of where the optimizer decides to read data from, you will always get a consistent view of your data. For example, if you run a select star from my table and that large scan goes to the object store, but you still have a bunch of mutations from recent DMLs in the row store that haven't been copied over yet, we will also retrieve those latest mutations from the row store and combine that with all the data from the object store. So again, you get one consistent view of your data, regardless of what the optimizer decides. Additionally, when we're reading data out of that object storage on analytical queries, we're also columnarizing and caching that data on the warehouse. So subsequent analytical queries against that same table will be more performant and efficient because they won't have to go to remote storage. So hybrid tables are now finally in general availability, but we've been hard at work listening to our customers and iterating on this feature based on customer feedback throughout the private and public preview. I want to touch on a few of the improvements that we made during the public preview that you can now take advantage of when you try this feature out in GA. First, hybrid tables are very much a performance-focused feature, and we've been hard at work to continue improving the performance of your workloads against hybrid tables. You'll see up to a 30% improvement in median latency for point operations against hybrid tables, and an even bigger up to 50% improvement for P99 tail latencies on point operations against hybrid tables. You can also expect similar improvements in the overall efficiency of the execution of those queries, allowing you to get more throughput from the same compute footprint. We've delivered an even larger 10x or larger potentially improvement in bulk loading when you're initially bootstrapping tables using create table as select. When we started the public preview, we went out the door with a fairly conservative 100 gigabytes of storage capacity limit per Snowflake account. That was a soft limit. We could go larger. Now, as we're moving into general availability, we've increased the limits to 1 terabyte per database. That's just the default storage quota. So if you need more storage for a larger use case, feel free to reach out to your account team or to Snowflake support, and we can increase the limits up to potentially tens of terabytes if it's needed for your use case. We have added support for time travel, so you can write as-of queries against your hybrid tables now, allowing you to do things like inspect the state of a table at a previous point in time, or if you accidentally introduce the corruption into a hybrid table, you could potentially copy the data from a previous point in time and restore that table to a healthy state. We've also added a new grouped query history user interface in Snowsight so that you get great out-of-the-box reporting on these sorts of higher throughput, low latency Unistore workloads over time. When we released hybrid tables into public preview, we also mentioned the aggregate query history account usage view, which gives you the ability to monitor key statistics about repetitive queries over time, things like throughput over time and latency distributions over time. Users gave us a bunch of feedback on that view and found it an effective way to monitor their queries, but they really wanted to have better visibility without needing to write SQL themselves. So we built a new grouped query history user interface that sits on top of aggregate query history and the full Snowflake query history in your account usage views. And gives you out-of-the-box dashboards that show you a bunch of statistics like throughput and latency distribution over time, as well as giving you a list of the individual queries that were executed for that particular repeated query. So you can go look at individual queries, look at their query profile, see what the plans were, maybe identify problems or bottlenecks that you might want to look more closely at. It's worth noting that while hybrid tables is now generally available, this grouped query history UI is in public preview currently, and then we'll progress that forward to GA in the coming months. So now we have a good sense of what hybrid tables are, what improvements we've made to this feature. And I want to quickly talk about what we're seeing our customers do with hybrid tables in the real world. We tend to see their use cases fall into three main buckets. The first, most common bucket would be using hybrid tables as a basic metadata store. Things like application state for auth and activity, or for the state of large parallel data warehousing and data engineering workflows. And we see this use case applied across a broad range of industries and functions with customers like Siemens, Project Lead the Way, PowerSchool, MarketWise, and Gatehouse Bio. A second category is data serving, where customers pre-compute data based on all of the signals that they're ingesting and processing in Snowflake, and then they serve that data directly out of Snowflake using hybrid tables in order to get the latency they need for their APIs and applications. Types of data for this sort of use case can range from promotion treatments to pre-computed reports. And we see this being applied in industries like online gaming, cybersecurity, and real estate technology. The last main bucket that we see is customers using hybrid tables as the backend operational store for lightweight transactional applications, really taking advantage of the ability to do high concurrency, low latency point DMLs for internal business applications, B2B SaaS applications, and things like that. And we see this being done in industries ranging from financial services to manufacturing to the energy sector. We're going to quickly look at an example for each one of these use case categories to hopefully bring it to life a bit more and make it a bit more relatable. First, Siemens uses hybrid tables as the metadata store for state as part of their data ingestion engine architecture. They're a large multinational manufacturing company, and they have lots of different source ERP systems where they have to ingest billions of change records every day and process those into a single reconciled view of their business inside Snowflake. They have a custom orchestration engine that they built that uses hybrid tables to store workflow configuration, so sources and targets. They use it as a metadata cache, and they also use it for the thousands of parallel workers to concurrently write and keep track of the state of their various jobs all in one place. When they originally built this data ingestion engine, they were struggling with locking issues, trying to use standard Snowflake tables as the store for this sort of state. And they considered alternatives like integrating with another external operational data store to store this metadata, but it complicated their architecture quite a bit. Hybrid tables were able to address the locking issues that they ran into because hybrid tables use row locking for DMLs instead of table or partition locking that standard tables use for those same DMLs. And they were able to maintain the simplest architecture that they could by keeping that metadata directly inside Snowflake. As an online sportsbook, William Hill has a duty of care to ensure that they don't show certain types of promotions to various users, especially at-risk users. They can identify these sorts of users by ingesting and processing a bunch of signals from their applications and user data that they store inside Snowflake. They then serve that promotion treatment directly out of Snowflake using hybrid tables through their web and mobile applications. They chose to use hybrid tables for this use case because it gives them the latency that they need in order to make sure that their applications are responsive, and the concurrency and throughput that they need in order to handle spikes in logins on game days. This allowed them to simplify their architecture by eliminating the need to reverse ETL out of Snowflake into a different operational store to serve that data. And it also gives them confidence that their user data is safe because they're maintaining unified governance by keeping all of that data directly inside Snowflake. Mutual of Omaha rebuilt their customer journey application entirely on Snowflake as the backend data store. This application allows them to tailor product and policy offers for their customers in real time. So when a user calls into a Mutual of Omaha call center, that call center agent is able to look up and validate the customer, see all of the past interactions that that customer has had with Mutual, and tailor product and policy offers for that customer to ensure that the best products get to that customer to improve their user experience and drive outcomes for their business. In addition to offering this experience through their own call centers, they also expose the same data and operations through their web and mobile applications and through their third-party lead provider channel partners. Now, they use hybrid tables for the core lead processing workflow because it addressed locking issues that they were running into and gives them the concurrency and response times that they need for the transactional aspects of this application. They also use it for some of the relational data models like their customers. When they plugged hybrid tables into this application, it immediately provided more than a 10x improvement in the overall performance of this application. There's a few things that make this use case particularly powerful. For one, they join the real-time transactional data that's being written into hybrid tables as the system of record with all of the historical analytical data that they have about their users and their campaigns and their campaign marketing performance in order to analyze campaign performance and refine those campaigns over time. They also enrich this first-party data that they have with third-party provider data around user identity that they consume through native Snowflake data sharing to further enrich and enhance their ability to get the right offers to the right customers. And then in addition to all of this historical analytics that they perform, they are also doing real-time campaign adjustments based on the freshest real-time signals in hybrid tables to further improve their ability to get the right product and policy offers to the right customers. And they do that by doing these real-time analytics against hybrid tables without impacting the ongoing operational workload from that lead processing workflow by really leveraging that dual storage nature of the hybrid tables architecture. So they're able to bring together all of the capabilities of the hybrid tables feature on its own, and more importantly, the depth of integration into the overall Snowflake database and Snowflake data platform to bring a lot of value to their users and to their business. If you're finding any of the information that you've learned today about hybrid tables interesting, or if you find any of the customer use cases relevant to what you do at your company or inspiring you to go try out new use cases, get started and get hands-on with hybrid tables today. We've included links to a handful of tutorials and quick starts that will get you going from 0 to 60 with hybrid tables in just a few minutes. If you'd like to learn more about hybrid tables, check out the links to some of the other resources we're including here, like our blog, our documentation, web pages, and white papers. There's also a fantastic hands-on technical demo that my colleague Nagesh is giving as part of this same build event, where he'll show building out a high concurrency, low latency data serving scenario for marketing technology. We've also included a link to a session from this past summit in summer 2024, where a couple of our lead engineers talk in much greater detail about the underlying hybrid tables storage architecture, the design decisions that we made in building out that service, and how we've been approaching optimizing performance for this technology. In addition to the customer stories that I shared as part of this presentation, we've been working with a number of our other customers to highlight how they're using hybrid tables in their applications and architectures, and share those stories through blog posts that they've written or on our own Snowflake Unistore webpage. So check out the links to those stories here, and feel free to check back into our Unistore webpage, because we'll continue to expand this set of customer stories over the coming months and quarters. I want to thank you so much for joining me today to learn about what's new with hybrid tables. We're really excited to bring this new tool into your Snowflake toolkit and see how you're going to use it to simplify your application development and data architectures on the Snowflake Data Cloud. Thank you so much again. Happy building.